Hey you guys, Mr. Sal here. We're just going to solve this problem using a system of equations. All right, let's go ahead and read this first. Keegan invests $4,900 in two different accounts. The first account paid 5%, the second account paid 13% in interest each. At the end of the first year, he had earned $445 in interest. How much was in each account? So to write these two equations first, let's look at the two accounts. So let's define first our x and y. And specifically for me, and it doesn't matter for you, again, even using the letters x and y is not really significant. Unless you're going to graph, okay? But for me, I'm just going to use x and y because that's what we're going to use pretty much all the time. And you're going to see these two used often. But if you wanted to use an L, an M, an N, whatever letters you want to use, that's okay. So let's define these. So since it was money that was put into two different accounts, I'm going to say that X is the amount put in the first account because that's what it's talking about here. And Y is the amount put in the second account, which was talked about right here. Okay. That will allow me to write the two equations. First, Keegan invested $4,900 into the two different accounts. So X, the amount in the first account, plus Y, the amount in the second account, we know was $4,900. Next, we need to look at the interest earned, which totaled $445. But if we look at the two accounts, X and Y, how much was the first account paying out? Well, that was 0.05, which is 5%. We'll add this to the amount in the second account, which was 13%, so 0.13. Now that we have these two values, I'm just going to go ahead and manipulate this equation so that we have X or Y equals. In the other example we did X equals, so I'm going to manipulate this one by subtracting X from both sides to make it Y equals 4,900 minus the X. Now in the equation I can replace the Y with 4,900 minus X. So I have 0.05X plus 0.13, but once again I'm going to replace the Y with 4,900 minus X. And this all equals 445 from the equation. So I front this to give myself a little bit more space. Now we're going to go ahead and distribute that 0.13 into the parentheses. Alright, so you can see from the distribution, 0.13 times 4,900 is 637. 0.13 times the x is 0.13x, and that would be considered a negative term there. So when we combine like terms here, we have 0.05x minus 0.13x, which is a negative 0.8x. And plus 637 equals 445. Now we just need to subtract 637 from both sides. Now, some of you guys will be a little alarmed because this is going to give us a negative value. However, the coefficient of x also is negative, so it's not going to make that big of a difference there. And that would give us a negative 192. Finally, to solve this, we would just divide both sides by 0.08, negative 0.08, and that would tell us that x equals an even $2,400. So it's $2,400 in the first account, which we know from how it was defined in the beginning here. Next, we need to figure out how much we put, or Keegan put into the second account. So we're just going to use this equation, which we already solved for, in order to solve for y. So we'll rewrite it. Y equals 4,900 minus x, but instead of x we have 2,400. And that tells us right away that y equals $2,500. And we'll label this properly. $2,500 in the second account. And that's it. Again, you should check these based on your two equations. You could base it on the words as well, and hopefully that makes sense. For example, 2,500 plus the 2,400 is 4,900, but you'd have to check based on the two interest rates that you would have, or Keegan would have made $445.